I am T. Colin Campbell, 66 years of age, and I hold an endowed chair at Cornell University in the Division of Nutritional Sciences. My official title is Jacob Gould Sherman Professor of Nutritional Biochemistry. I'm also director of the China-Oxford Cornell Project on Diet and Health. In my research career, I started out from a very traditional point of view, where protein was important, where the typical Western diet was considered to be the best. And my views on plant-based nutrition gradually evolved over the years, beginning with some work with experimental animals, in particular during the 1960s and 70s. Finally, in 1980, I was on a National Academy of Science expert panel looking into the question concerning diet and health, diet and cancer in particular. That was a rather important event, and then we got involved in the China study and continued the experimental animal research. The evidence became clear that it was consistent when looking at different kinds of studies, and it was very clear that this evidence was in favor of a plant-based diet as being the healthiest way to consume food. The China study was started in 1983 and continued a little bit, at least as far as the survey was concerned, into 1984. And then from 1984 until about 1988, we were analyzing all the samples that we had collected. And from 1988 until 1990, we were sort of computerizing the data and cleaning the data, and it was eventually published in late 1991. It was funded by the National Institutes of Health here in the United States for 10 years, as well as the American Institute for Cancer Research, as well as to some extent the Imperial Cancer Research Fund of Britain. It was a joint project between Cornell University, University of Oxford in England, Radcliffe Infirmary in particular, as well as two major government academies in China, the Chinese Academy of Preventive Medicine and the Chinese Academy of Medical Sciences. As far as funding was concerned, of course there was the money that was provided by the National Institute of Health and these other organizations, but in addition the Chinese government actually contributed in kind, according to my estimate, more than 800 person-years worth of professional labor. It was enormous. And so, in many ways, the contribution of the Chinese government was more substantial even than the contributions from the Western governments, although the contribution of the Western governments involved cash, and that was important. The China study was an attempt to look at the relationship between diet and lifestyle and disease in a very different context than what had been previously considered in Western studies. Namely, virtually all Western studies involving diet-disease relationships are concerned with looking at populations that are traditionally consuming Western diets, ranging from, on the one hand, diets rich in animal food, to, on the other extreme, diets very rich in animal food. Virtually no studies had really looked carefully at the activity or the association between diet and disease, where diets might range from diets rich in plant food to diets very rich in plant food. So we're looking at a different sort of perspective, a different region of dietary experience. And that was important. And as we started looking at the relationship between diet and disease in that segment of our experience, we were learning quite conclusively that however we looked at it, the relationships that we were getting there showed that the closer we got to a plant-based diet, the healthier it was. And that was the kind of information that was being inferred at this other range, the Western studies. That's what, in my view, made the China study so provocative and interesting, because it was saying that the closer we get to a plant-based diet, the healthier we're going to be for a variety of health problems, if you will. Diseases, obviously, in particular. The China study was relevant in more than just the scientific sense, more than just the study design sense. It was relevant because consuming a plant-based diet really has enormous implications It not only creates health, which we obviously need, but it could, if taken seriously, have a major impact on our way of thinking about health. It should have a major impact on the way we actually fund research. It has a major impact on the way we think about the environment. And I would argue that when one starts thinking about the philosophical and historical basis for this information, it has some major implications there too as well. I am particularly fascinated with the idea that we tend to do science in the West in a rather specific kind of way that is not entirely consistent with the study of this type. So I'm basically suggesting that the China study challenges some of the very basic and fundamental concepts that have become so dear to us. We're talking about a whole new realm of scientific and medical thinking, as well as a whole new realm of eating and treating our environment appropriately, and dealing with the question in an economically and politically different way as well. It's a major shift. The medical and scientific communities here, when they first heard about the China study, were rather impressed, I think, at least according to the early reports. Science itself had an article talking about this was an experimental laboratory of a very unique kind. It was featured as a cover story in the New York Times. Of course, that's not a scientific journal, but it was featured there. It was featured as a cover story in USA Today, Saturday Evening Post. And there was a lot of discussion about the China project at that time that indicated to me that this scientific community in general were rather excited about this, rather impressed about it. But I must say that their impressions primarily were related to the fact it was a different opportunity. The study was designed quite well. It was comprehensive. So the scientific characteristics of the study were considered to be good. It wasn't until a little later I started talking about the interpretations of the data, particularly in this sort of plant food, animal food context. Then, at that time, although I don't get argument really with my interpretations in that sense, it nonetheless, because it tends to provoke some major changes in the way we think, it obviously has created a lot of provocative discussion. But as far as the study itself is concerned, I should say that this is, in fact, generally regarded as the most comprehensive study of diet, lifestyle, and disease in humans ever conducted, in science or in medicine. And it's a different way of looking at the relationship. In other words, I am much more impressed with the idea of looking at diet and disease relationships from a much more comprehensive point of view, as opposed to looking at single things. I mean, I really find that looking at the relationship, for example, just to use one or two examples, look at the relationship between fiber intake and colon cancer, which is fairly traditional, or looking at the relationship between fat intake and breast cancer, or any number of other sort of relationships like that. I find that when we do things that way, particularly when used in the Western population who are accustomed to doing things their way, when we look at things in such a narrow fashion, we can get information that can be readily taken out of context and misunderstood. And it doesn't tell us anywhere near the full story that we can get by looking at things more comprehensively. So that was the purpose of the China study. Let's look at things comprehensively. Let's use a population that really is getting close to a plant-based diet. If we're going to test the hypothesis as to the value of plant-based diet, we should be studying people who are mostly consuming plant-based diets. We hadn't done that before. We have been studying people who are just changing their fat intake a little bit, or changing their intake of some nutrient supplement, or changing their intake of dietary fiber, or something like that. Amongst populations who are consuming mostly an animal foods-based diet. I think you can see the point. That gives very limited information and can be too readily taken out of context and can be too confusing. It most certainly is too confusing to the public. So what we need to look at is the full range of possibilities, and when we look at these range of possibilities between diet and lifestyle, we should look at it, again, very comprehensively, look at many different things, and begin to sort out the patterns. That's where the really important information comes. And that's why I can make this very sweeping generalization that getting closer to a plant-based diet gives rise to better health from many different perspectives, involving a variety of diseases and involving a variety of health outcomes. In regard to the China study and its investigation of the relationship between plant food intake, if you will, and these various disease outcomes, I could mention some specific examples to illustrate the point. Dietary fat and breast cancer relationships have often been discussed, as we all know. The studies that had previously been considered in the Western literature was looking at the range of fat intake from, say, about 45% of calories down to maybe 25 or 30% of calories. That's the typical Western range, where the average is about 35% of calories or so. And what we see in those particular conditions is that as fat intake has decreased, in a general way, it was generally considered that breast cancer rates should be decreased. Unfortunately, in some of the bigger studies, such as the Nurses' Health Study at Harvard, they did not see a decrease. And this illustrates my point about looking at things in isolation. What really happens in that study is that these 100,000 or so nurses are consuming a very traditionally Western diet that is comprised mostly of animal-based foods. The average intake of animal protein, for example, is about 80%. I mean, they're getting close to being carnivores. And so what these women have been told to do, as women in general and men have been told to do it from the Western studies, take out the fat, get it down. You know, use low-fat milk, for example, or skim milk. Use lean cuts of meat. Don't add so much oil and fat and spreads and so forth and so on to your dishes. Don't use fried foods. And so I think a lot of people have been somewhat successful in getting their fat intake down by doing that, but they have not changed their diet, you know, in the context of changing from animal-based foods to plant-based foods. So as a result, when they take out the fat alone, the animal protein intake, for example, which is already high in the beginning, gets even higher. And under those circumstances, we don't see an effect of fat, obviously, because what may have been gained on the one hand by taking out some fat, and there's good evidence to suggest that there should be some gain, what is theoretically gained on the one hand is lost on the other. That's why studies like that don't work, and they cause a lot of confusion with the American public. Now let's go back to China. In the China study, we wanted to look at the relationship between fat intake and breast cancer. Okay. The fat intake in China was between 6% of calories on average, in the lowest fat consuming county, up to a high of 24%. So we're talking about going from 6 to 24, compared in the American or Western context, going from about 25 to 45. So we're looking at a new range down here. Under those circumstances, the Chinese were getting their fat intake down not by necessarily using less fat, but rather actually getting away from the consumption of animal-based foods. And they're already low. When we talk about 24% of fat, that's equivalent to animal-based foods containing about 20% of the total energy coming from animal-based foods. So it's already low. We're talking about going from about 20% animal foods diet down to about 0%. That's how they get the fat intake down. In that context, as fat intake comes down, it becomes just a sort of an indication, you know, the changes in the whole diet. And in those circumstances, what we observed, rather surprisingly, quite frankly, was that as fat intake comes down and animal food intake goes down and fiber intake tends to go up, of course, under these circumstances, breast cancer rates go down. So that was an indication that there's something going on here, that the closer we get to a plant-based diet, as indicated by a low-fat intake, as indicated by a higher fiber intake, and all these other marvelous things that go on, breast cancer rates become very low compared to the West. On another example, in the China study to illustrate this effect of plant-based diets on disease risk, I could mention the relationship between blood cholesterol and its association with various and sundry Western kinds of diseases, such as heart disease and different kinds of cancers. The cholesterol range, the blood cholesterol range in China went from a high of about 170 milligrams per deciliter down to 90. The average was 127. So we're talking about quite a low range. In the Western context, our comparable range goes from about 170 milligrams per deciliter up to about 300. In other words, the Chinese high was near our low. So now we're talking about a low cholesterol range, total cholesterol range, and we're talking about what is the relationship of this blood cholesterol with these various disease outcomes. And it turns out that the cancer rates tend to go down as you go from 170 down to 90. In addition, when we looked at the dietary factors affecting these blood cholesterol levels, it turned out that cholesterol levels go down and down and down as a function of getting closer and closer and closer to a plant-based diet. I mean, quite remarkable. And so what it basically said was that as soon as cholesterol levels start to go up from 90 on up, creeping up towards 170, as a function of putting in a small amounts of animal food and changing the diet in that direction, these diseases start to appear. And so you can well imagine by the time we get to 170 in the Western context and then continue on up to 250, 300, 350 or whatever, now we're talking about really major changes, you know, in dietary experience. I mean, there were a lot of studies or a lot of specific investigations of the China data that we could look at, involving antioxidants and various disease outcomes, or blood cholesterol and disease outcomes, or any number of other things. And it turned out every time we looked at these sort of more detailed sort of relationships, almost every time we looked, what we found was the same answer, just glaring at us, kind of hidden maybe from view to look at any one relationship sometimes. But nonetheless, they were all sort of going the same direction. And that was the closer we get to a plant-based diet, the healthier we're going to be. End of story. It's very clear. And one study in and of itself is always not the answer, necessarily. But what makes this information from the China study, I think, even more impressive is the fact that when we look at these relationships in the China study and then start comparing it with some other studies, or with experimental animal studies, or with the reversal of advanced studies, for example, or advanced diseases, for example, as we tend to do that, we find a lot of consistency, you know, looking at all these different kinds of findings. Animal-based foods tend to create, as far as their metabolites are concerned, their products, animal-based foods tend to create an acidic urine, for example, coming from the fact that animal-based protein, specifically, has some sulfur amino acids, which when they get metabolized produce sulfate ion. That's an acidic ion. And as this is coming through the kidney, getting into the urine, the body actually doesn't like all that acidity. And so it pulls on some alkaline buffer to neutralize this. And it grabs the calcium. That's the best source. It pulls the calcium out of the bones to neutralize it. And that's the relationship between the consumption of animal-based foods on the one hand and loss of calcium on the other, which intends to suggest that when we're eating animal-based protein-based diets, we're going to lose more calcium. And therefore, bones are going to become weaker. Fracture rates are going to go up. And osteoporosis rates should be higher when we're consuming more animal protein-based diets. And that's precisely what has been reported by others. It's very clear. In Western countries, or in countries in general that consume more and more animal-based foods, they have higher and higher and higher rates of osteoporosis. It's quite remarkable. And there are other studies showing, for example, amongst humans, that there's a reason for this. It's plausible. As I said, it's the intake of animal protein becoming higher and higher and higher, creating this acidic environment that has to be neutralized by pulling out the calcium from the bones. It's really very impressive. Chronic degenerative diseases, which include heart disease, the various cancers, diabetes, the kind of diseases that actually kill us, most of us, before our time. Those kind of diseases are much more common in so-called Western countries. The countries that are more industrialized, countries that have become more accustomed to the consumption of animal-based foods and fast foods and fractionated foods, processed foods. Those countries are the ones that, as I said, have the highest rates of these diseases. It seems to be a phenomenon of industrialization. Some people inappropriately have referred to as a phenomenon of civilization and of affluence. I don't quite call that civilization in my view, but they're called diseases of affluence as well. I would rather call them diseases of nutritional extravagance, because that's really what they are. And one of the main things we do as we get money and industrialize and can sort of purchase what kind of foods we want, one of the things that we inappropriately do, and this generally applies to almost every society in the world, as they start getting money, one of the first things they want to do is to consume animal-based foods. I mean, I see that in rural China, where just in recent years, as they've been getting more money, they're starting to change their diets. And in urban China, for example, now they're sufficiently capitalized and have enough wealth, for example, to actually have rates of cancer and heart disease are like us. Their diets are now around 30 to 35% of calories as fat. That's very close to us. They've become quite westernized. In Beijing alone, I was just there 2 months ago, in Beijing alone, there's now 150 McDonald's stores in Beijing. I mean, it's sort of the Western way. And if one goes back and looks at the literature, it seems like these Western kind of diseases, the heart disease, the cancer, the diabetes, and so forth and so on, these kind of diseases, I mean, we knew that that kind of thing happened 100 years ago, 150 years ago. You could see these sort of trends happening. And oftentimes in the past, people did in fact conclude that this was related to the increase in consumption of animal-based foods. This information has been around quite a long time, very long time in fact. So what we need to do is to figure out how do we go back to where we were, while at the same time not incurring the problems that we had, because in earlier times before industrialization, whereas we maybe mostly consumed more plant-based foods, on the one hand, we had to put up with a lot of other rather difficult problems, such as public health conditions, such as not having good variety, such as not having good quality of foods. So as a result, we had other problems, such as the Chinese have had, you know, in the poorer areas of the country. But if you look at all this information and weigh it, and take the best of the two eras. On the one hand, we can learn that consuming plant-based foods is the best way to create health. On the other hand, we can also learn that there should be good quality and good variety. And we should keep our environment in good order. And obviously we should have good public health facilities to keep communicable diseases under control. And so we take the best of the East, the best of the West, and put it together, you know, in a diet that is comprised mostly of plant-based foods, high quality, good variety, and, you know, staying clear of all the chemicals we tend to add to our food and to our environment. Now we got a formula that is getting very close to creating optimum health. Yes, when we compare a plant-based diet with a diet that's comprised largely of animal-based foods, what we now can say is that there are no essential nutrients in animal-based foods that cannot also be obtained to much better advantage from plant-based foods. bar none. Is of all the nutrients that we think about, both in the public as well as in the scientific and medical communities, that seems to command the most attention historically, it's protein. I think most people would agree to that. Even the word protein, when it was first coined in 1839 by a Dutch chemist, because he thought he found the real stuff, he called it, he took the name protein from the Greek word proteos, which means of prime importance. And so from this very auspicious beginning, protein has always been considered to be the singular, most important protein. And eventually, during the 1800s and early 1900s, it became synonymous to a considerable extent with meat, because meat contains a lot of protein. And as was discovered in the late 1800s and early 1900s, the protein of meat actually got utilized more efficiently. So it got to be called high-quality protein. And you can imagine what effect this had on the public who might be hearing this as a story. I want high quality of this very special stuff. And so the entire justification and enthusiasm that arose surrounding the so-called nutritional value of meat centered to a great extent on the question concerning protein. And even today, one of the first questions people want to ask about a plant-based diet, does it have enough protein? And my answer to that is, of course it does. We do not need the protein from animal food. If we're consuming a variety of plant foods, particularly plant foods that contain some legumes and some leafy vegetables, obviously, and some whole grain material, there's plenty of protein in there. There's plenty of protein. We do not need more. First. Secondly, it's the right kind of protein. It is used in a sort of biological sense less efficiently, as the saying goes. That is, we may take a smaller proportion of the protein to actually put into our tissues, which was considered in the past to be a bad thing. But it's a good thing. I mean, I don't know why, for example, increasing the efficiency of protein utilization in animal-based foods is considered to be a good thing. The protein is the wrong kind. I don't want to use something that is doing the wrong thing more efficiently, to be honest about it. What we're now learning from investigations on protein, and that was incidentally the one area of research that I have continued ever since I was in graduate school. What we're now learning is that high intakes of animal-based proteins, as illustrated with casein, the principal component of cow's milk, that protein, that kind of protein, really has a number of very adverse effects. Casein, for example, has been shown for many, many years, and we did some of these kind of studies ourselves. Casein has the capability of elevating blood cholesterol levels, even more so than dietary fat, and certainly more so than dietary cholesterol itself. So casein has this ability to increase blood cholesterol, which in turn increases the risk for these diseases. Mind you, I remind again, we're talking about cow's milk protein. Furthermore, in studies in our own laboratory over many years, research that was funded for 19 consecutive years by NIH, I should point out, involving more than 100 publications in the peer-reviewed literature. What we were essentially able to show in those studies with rats and with mice, that we could take casein when fed at normal levels of intake and just watch tumors grow. We could take the casein away and turn off the growth of these tumors. We could put casein back in again, turn tumor growth back on again, take it away, turn it off. We could do many of these different kinds of sort of combination studies, such that we could essentially control the growth rate of tumors in these experimental animals simply by giving them normal levels of casein, what is generally considered to be normal, like 20% casein. I mean, just a regular level of casein could do this. It wasn't anything excessive. It was the kind of levels that we consume, either as casein or as other animal-based proteins. So I would argue, as I did in a seminar at Cornell a little over a year ago, that of all the carcinogens that we consume, such things as pesticides, herbicides, all these other odd chemicals that we get exposed to, which are bad stuff, mind you. But of all these, if we apply the same rules for the determination of the carcinogenicity that we do to those chemicals, we apply that to the test of casein. Casein is the most important chemical carcinogen that we consume. That's one point. So now we got casein, is like other animal proteins, is able to elevate plasma cholesterol or blood cholesterol. It's able to influence tumor growth rates, turn it on. It's able to influence, as other animal proteins do, it's able to influence the development of type 1 diabetes. That's the insulin-dependent diabetes. As the casein gets broken down, it's not so much the casein, but it's other milk proteins, as it gets broken down in the gut, as it gets digested, it's supposed to, in theory, go all the way to the amino acids. But some of it doesn't. Some of it comes down to little fragments of chains of amino acids called peptides. And these little chains slip through leaky guts, particularly of infants. And there's one 17 amino acid sequence, one chain of 17 amino acids. When it comes through, gets into the blood, the body looks at it, says it's like a foreign protein. It makes an antigen against it to destroy it. Well, it turns out that's a good thing. That's the body's reacting the right way. But it turns out that that antibody that's been created to destroy the 17 amino acid sequence then turns around and finds another identical 17 amino acid sequence on the pancreas, on the surface cells of the pancreas, which is responsible for producing insulin. So it goes over here, destroys this casein bit, comes over here to see the pancreas, destroys that. And once this infant, this very young child, loses these pancreatic cells, it therefore loses its ability to produce insulin for the rest of its life. So here you have type 1 diabetes, which makes up about 10% of the total diabetics in the country, but it's a very serious kind of diabetes. So now we have casein increase in blood cholesterol, we have it turning on cancer growth rates, and this has been demonstrated beautifully in different kinds of tumor systems, I might add. It creates the opportunity, at least in a few individuals, for the onset of type 1 diabetes. Casein and probably the other proteins in dairy, for example, do a number of other things. There's been associations with things as odd as the creation of cataract, greater incidence of cataracts. Childhood allergies seems to be, in its many different forms, seems to be associated with the consumption of dairy products. And so it goes, and the list is growing. And this is a list of very serious outcomes. And so I've arrived at the conclusion, in spite of having milked cows until I went away to school, in spite of having done my doctoral dissertation on trying to figure out how we could produce more of that kind of protein so we could all be healthier, in spite of all that background, I've now come to the conclusion that one of the most serious problems we have in Western nations is the consumption of cow's milk. And I really have no doubt that, but in the near-term future, we're going to hear a lot more discussion about the adverse effects, the adverse health effects of dairy compared to what we have heard before. And I just would make one final point, and that is that the dairy food, the things that we're learning now, that almost seem kind of new, when you go back into the literature, some of this information has been around for a long time, for 50 to 75 years. Very nice research. And so there is yet another question. Why has it been hidden from view? Why does the public know this? I mean, we tend to think that protein is so important, and we think that milk is food from heaven. And, you know, because it has all this nice protein, because these days it has calcium, so it's said. And it's going to be a tough sell, I think, to some extent, for obviously a lot of people. But the evidence is becoming abundantly clear that cow's milk is a serious problem. And now we got alternative kinds of products that we can use. Instead of cow's milk, get away from that. I just find it kind of strange that actually we as a species, it's the only species, I can't think of another species on the face of this earth that decided to go around and suckle the milk of another species. Kind of odd. Cow's milk is perfect. It's a perfect food, but for calves. Human milk is a perfect food, of course, for babies, for human babies. But cow's milk being given to humans after they've been weaned makes no sense. The story concerning the adverse effects of cow's milk, and more particularly the adverse effects of cow's milk protein on various health outcomes such as increase in cholesterol and heart disease and the like, those kinds of studies have been largely attributed just to the simple, pure effects of the protein in the milk. And I'm talking about good milk, pristine milk, if you will, for the most part. And that's the way milk had been through the ages, and we're learning now that wasn't a very good idea. But if that wasn't a very good idea, the milk we're getting today has got to be considerably worse. And I say that for the following reasons. First off, many of the cows these days are being injected with bovine growth hormone, or BGH, in order to stimulate milk production, supposedly so we can have more milk. Which sounds rather a ridiculous idea to me. But the animals are being injected with bovine growth hormone, which tend to increase their milk consumption, sure enough, by 15–20% maybe or so. But it comes at an expense to the animal. That is to say, in order for the animal to produce 15–20% more milk, its udders become 20–25% larger, much more pendulent, and as a matter of fact, if one looks at the cows in these kinds of situations, their udders are practically touching, or even they are in fact touching the ground at times. And so these animals in fact aren't even sent out to pasture like they used to be. They're kept more or less in their short lives in the barn. And when the udders are in that form, in that condition, irritation, inflammation arises, infection arises, and a condition called mastitis occurs. In order to control the infection for these animals, we have to inject more antibiotics into the udders. And this is done routinely. And so the cows these days are receiving much more antibiotics that end up in the milk. And in addition, because of the infection, the milk these days has quite a cocktail. Now we got some hormones to go along with the previous stuff. We've got some more antibiotics, and we've got some more blood and more pus that comes from the infection. And if that sounds like an ideal food, then I don't know what an ideal food is. Well, in our studies on the relationship of food to disease production, we tend to characterize this relationship by the nutrient profiles in the various foods. In other words, how much fat does it have, how much protein, what kind of protein, how much fiber, what kind of antioxidants, things like this. And in that sense, animal-based foods are distinctly different from plant-based foods. Animal foods have cholesterol, plant foods don't. Animal foods have very little or no antioxidants. Plant foods have all the good antioxidants, which may be measured in the thousands. Animal foods have no dietary fiber. And there's probably hundreds, if not thousands, of combinations of dietary fiber. Plant foods have the fiber. So plant foods have the fiber. They have all these different antioxidants. Generally speaking, they have much less fat. In other words, there's a really distinct difference between these two major classes of food. And so when we look at food that way, and that's what characterizes their ability to maintain health or create disease. Plant foods, with this very unique sort of profile of nutrient composition, have beneficial effects on preventing disease and promoting health. Animal foods, in contrast, although they may differ to some extent between one and another, nonetheless, as a group, they tend to act as a group, as opposed to plant foods. The animal foods basically, obviously, create health problems. And so when we think of it that way, then, and we ask ourselves, where does milk fit into this? And if we look at the nutrient composition of milk, it's very clear. The nutrient composition of milk is nothing more than another animal food. And so therefore, it's not surprising to find that it produces the same effect as many other animal foods, and maybe more so. I like to call milk basically nothing more than liquid flesh. Yeah, on the question concerning the relationship between genes and nutrition, if you will, we need a little background information. Every physiological process, virtually, such as disease formation, begins with genes. In other words, genes are the fundamental blueprint of all physiological processes. In other words, it's the DNA. So we're learning now a great deal about all over 100,000 or so genes that we have. Everything begins with the genes. It goes from DNA to RNA to protein, the enzymes and so forth. I mean, it's that sort of pathway. So we are a product of our genes in that sense. Okay. Now, of all these genes that we have, some of us have genes that have been maybe mutated, changed, or slightly altered in some other way to give an increased risk for some kind of disease. So we have a gene or two or three or whatever, I think it's 7 or 8 genes now, that seem to contribute to obesity. They're called obesity genes. We've got a couple of genes that seem to contribute to the formation of breast cancer, BRCA1, BRCA2. We've got genes that have been isolated to contribute to colon cancer. And so we get impressed with the idea that these genes, if we have these genes, we're going to get the disease. That's the sort of hypothesis, that's the thesis, that's the underlying sort of message that's coming out to the American public at the present time, unfortunately. What is forgotten in that story is that these genes, here you have the DNA, these are the genes, they get translated into RNA, and then from RNA into protein, which turn out to be largely enzymes, that then contribute to disease or not. If we got some bad genes, you know, we should not be making the conclusion that those bad genes are going to give rise to the disease at the end point. That's not the point. The point is, how do these genes get expressed? And what I mean by that is, how do these genes actually synthesize the RNA? And how does this RNA get synthesized in protein, get synthesized in the enzymes that contribute to disease? There's a whole many steps here. So even if we have a bad gene over here, we basically can control the expression of those genes by good nutrition. That's what we're learning. And when I say good nutrition, it turns out it's plant-based nutrition. Because as we begin to explore these relationships, the nutrients present in plants, either singly or as a cluster, tend to keep under control bad genes that we may have. Bad genes, I'm using the term a little bit advisedly, because bad genes can come from genes we may have been born with. They also can come from genes that are mutated or changed during our lifetime because of some attack with some chemical, such as a mutagen. So we can have either of those kinds of genes that we're born with or created after we're born, but nonetheless they have to get expressed. And so we're now finding that genes really have very little to do with disease formation if we eat the right food. And the whole notion of people believing that diseases run in families because we have the genes, such, for example, is a very fatalistic view. And in my view, it's an attempt, either intentionally or unintentionally, it's an attempt to not take responsibility for what one does with their lives. For those who wish not to change their diet or don't want to believe this, they say, oh, it's in my genes. And they just sort of, you know, eliminate from their mind because now they've got another excuse. But the fact of the matter is, if they make the right choices, they can control the expression of these genes. Not in every case. I mean, I confess, there are some genes that are obviously very deleterious and may be controlled only with great difficulty. But those are the rare genes, quite frankly. It's the common genes I'm talking about. Heart disease and cancer and diabetes don't come from, even though it begins with a gene action, we should not confuse that with the fact that it has to do with the turning on of these genes that really matter. That's the question. It's turning them on. And nutrition can control whether you turn them on or turn them off. On the question concerning the evidence of whether or not genes are important in causing human disease, there's one kind of study that's really particularly interesting. It's the so-called identical twin study. Identical twins have the same genes. Non-identical twins don't. I mean, just like another pair of siblings. And so if genes are really important, one would expect the identical twins to get the same diseases, more or less at approximately the same time, let's say. And there's been about 5 or 6 of these kinds of studies now. And of the evidence that I have seen, one of the largest being that of the National Institutes of Health, of some 5,000 and some identical twin pairs compared to 7,000 and some non-identical twin pairs, there's virtually no evidence. The risk of, let me say that, the risk of getting disease amongst the identical twins, the same disease, is really not much greater than the risk of getting the same disease for the non-identical twins. In other words, there's no greater likelihood, really, of the identical twins getting the same disease than the non-identical twins. Now, there's been another study that came out just about a week ago that was in the newspapers, and all I know is what I've seen in the newspaper, so I haven't had a chance to look at it. They concluded apparently that, and it was apparently came as a surprise to the people who were doing it. They said, wow, it looks like diseases aren't caused by genes as much as we thought they were. I don't know what the fractions are, but there was some implication in the newspaper article that that genetics was more important than what I just indicated. It does contribute something. But sometimes we misunderstand the relationship of genes to disease simply because people with the same genes may have a slightly greater propensity to getting the disease. But that also can come from the fact that those individuals were in the same womb and did not necessarily have only the same genes, but also had the same in utero experience, which can create lifelong effects, which gets inappropriately, assessed as genetic determinism when in fact it's not. But in a general way, the human studies on comparing identical twins with non-identical twins indicate that genes have very little to do with the determination of ultimate disease. There's other studies. If one looks at the people living in countries where the risk of disease is particularly high, for example, and they move to a country where the risk of that disease is particularly low, and they don't change their genes, in other words, they don't intermarry with the local population, they get the disease of the country to which they move. And on the basis of that information, it was generally concluded some years ago that genes did not contribute more than about 2 to 3% of the risk for cancer, for example. And yet there's other studies. There's studies involving genetically programmed experimental animals, genetically programmed to get certain diseases, such as cancer. We did some of these studies ourselves, whereby we can intercept the expression of those genes to produce that cancer simply by manipulating, in this case, the protein of cow's milk. It's dramatic. So there's all kinds of evidence now indicating that genes, although they are at the basis biologically for these events, nonetheless their activity can be controlled. On the question concerning the influence of nutrition on genetic action, it's my view, and I think the evidence supports this quite well, that this effect can occur very, very quickly. In our experience, at least experimental animals, if one changes, for example, the protein intake, we can see those results in a matter of hours. A matter of hours, certainly a matter of days. And what we tend to see, that's a qualitative kind of thing. When we see that in animals, I'm sure that the same thing exists in humans. There's some human data too, to show that you can change the nutrient intake, and within almost minutes, certainly within hours, you can see changes in the rate of enzyme synthesis, which is the end product protein that comes from the genes. So you're really affecting gene expression. And so even though we may have these genes for all of our lifetime, and we do, we can manipulate. I liken it to, we got all these faucets that can be turned on. We can turn them on and turn them off very quickly. Yes, one of the questions that have been raised about a plant-based diet for a long time is that it doesn't have enough protein and it may not support good athletic performance. However, it turns out that there are athletes who have reached world-class status, who have been, in fact, either vegans or virtual vegans for the most part, and have done it because they were, at least they chose that lifestyle in order to be world-class athletes. And I teach a class at Cornell University, and in fact decided to invite such people, to come, such as Dave Scott, who was the Ironman triathlon champion for 4 years, and really an incredible feat. Some considered him to be the world's greatest athlete. He at the time was a virtual vegan. Martina Navratilova, Carl Lewis, the world champion wrestler, Chris Campbell, is really quite a story. He was a Big Ten champion in wrestling for 2 successive years. He was not the heavyweight, but the next class just below the heavyweight. And he decided he wanted to be in the Olympics in 1980. And he decided he wanted to eat the right food because he felt that was important. He was married to a woman who was a nutritionist by training. And he on his own discovered or decided that it was a vegan diet. And so in the run-in to the Olympic trials just prior to the 1980 Olympics, he was in those trials, and he beat the previous gold medal winner just before the Olympics. He beat him 14-1. And he was a shoo-in to be the gold medal winner. Unfortunately, the United States pulled out of the Olympics that year, so he didn't get to go to the Olympics. But he went into the World Championship wrestling matches, and he was four consecutive years, he was a world champion wrestler. Came back to Cornell, got a law degree. And then finally in 1992, he skipped the next 2 Olympics. In 1992, he decided to go back at the very old age for a wrestler of 37 years of age, just to see if he could make the team. He ended up with a bronze medal. In fact, just missed the gold medal. And he was the guy who represented the American Olympic team in George Bush's White House when he returned. It's a remarkable story. And then going back and looking at the literature to some extent and finding out whether or not this story has any validity that, eating a plant-based diet was going to compromise one's physical performance. I have found some really quite remarkable stories that people who chose to do that in the past and then competed against, let's say, non-vegetarians or meat eaters, the vegans always won. They always won, and not only in body, but also in mind. I mean, people like Tolstoy, Leonardo da Vinci, Albert Einstein, I don't think they're, or Shaw. I don't think these people are, deficient very much in their mental capacity. They were vegetarians or vegans. So this whole story even becomes older and older and older back in the days of the ancient Greeks. And Plato's dialogues, where he's talking about Socrates, it's acknowledged there, so to speak, what Socrates said, supposedly. They all knew that to be an Olympic athlete, and that's of course where the Olympic idea started, to be a high-class Olympic athlete, everybody knew you had to only eat plant food. That was known at that time. And in fact, there's some really marvelous writings in the ancient Greek times advocating a plant-based diet. Not necessarily just for health, although health was acknowledged, and there were some very interesting comments made about that, but also for sort of philosophical reasons as well. I mean, Pythagoras himself was essentially a vegan. And the people who followed his advice for a long time were called Pythagoreans, because that word vegetarian hadn't yet been invented. And so these ancient thinkers, great thinkers, were in fact aware that consuming a plant-based diet created the best kind of mind and body. Incidentally, the word vegetarian didn't come into view, or wasn't figured out, until somewhere in the 1800s in Britain. And it doesn't really come from vegetable like a lot of people think. It comes from the Latin word vegetus, V-E-G-E-T-U-S. And vegetus means strength of mind and body. And so the word vegetarian means strength, not weakness. In many of the studies that have been conducted in science in recent years, comparing, for example, non-vegetarians with vegetarians, we see beneficial effects for vegetarians. It's quite clear and it's fairly consistent. But those benefits sometimes seem somewhat marginal in some of these studies. But nonetheless, they're there. Now we're learning that the real benefits to be gained is not to become a vegetarian, because 90% of the vegetarians are ovo-lacto vegetarians, which means they're consuming milk and eggs. And so when we compare non-vegetarians to vegetarians, we're looking at vegetarian diets that are not that different in terms of nutrient profile from the non-vegetarian. So we see some benefit, but not a big benefit sometimes. The real big benefit comes when we go from vegetarianism to veganism. In other words, we eliminate the dairy and the eggs. That's where the important achievements are really made. On the question concerning the relationship between the consumption of a plant-based diet with athletic performance, we now know that consuming a plant-based diet enhances athletic performance. Some of the great athletes of the world have learned this. People such as Martina Navratilova, Carl Lewis, Dave Scott, the triathlon champion, Chris Campbell, the world champion wrestler, Parrish of the Boston Celtics, for example, I think he's 7 foot something. There's a number of these people who have actually done this and have learned, in fact, that their athletic performance is enhanced, improved, and they're able to achieve their great feats. I mean, Carl Lewis has won more gold medals than anyone else. For example, Dave Scott, no one compared to him in terms of competing in that triathlon event. To be a world champion wrestler, of all things, eating a vegan diet, what a strange phenomenon. I just find this information so profound, so comprehensive, so beneficial, so potentially of enormous potential benefit to all of us, and so old, and I am troubled by the fact that we tend not to know. I'm troubled by the fact that much of this information was achieved with taxpayer money, at least in this country. I'm troubled by the fact that using taxpayer dollars, this kind of information has not been made more available to the American public so they know it. And to get to the point, I'm particularly troubled by the way that politics and economics play a role in this. I can appreciate to some extent these kind of forces and why they occur, but I find it very difficult to understand how political considerations and political decisions can be made to, quite frankly, keep this from the public. And I know I'm making a very provocative statement, but I'm finding, in fact, that politics and the interests of special interest groups have interfered in the process, have begun to corrupt the academic environment, and have created policies, in fact, that are not in the best interest of the public, because the people who are making those decisions are looking out more for the interests of their special interest groups than they are for the public at large, and certainly for the taxpayer who's paying the money to get this. There is one particular program, I might say, that needs to be considered very, very seriously. It's the school lunch program. The school lunch program is a program whereby something like 26 million children every day consume that lunch. The nutritional characteristics of that food, of that lunch, is actually poorer than even the average American diet for adults, and children are vulnerable. And in order for schools to participate in the school lunch program, they have to offer dairy. And the reason they have to offer dairy is because the industry, through their friends at USDA, have insisted that that subsidized program has a marketing outlet. So the dairy essentially is forced. I mean, in my view, it is essentially forced on these children, 26 million children. And the children who, in fact, are most vulnerable are the Hispanic and African American children who have a higher lactose intolerance, which is an indication of their susceptibility. They're the ones who most often are the ones who usually have to take the food. And I just find this to be just abominable, unacceptable, and it turns out one of the reasons this is so important is because we now know. You can take children, as was demonstrated by a graduate student at Cornell, Dr. Antonia Demas. you can take children and teach them. And you know, at these very young ages, in the kindergarten, first and second and third grade, you can teach them about this other kind of food. You know, low-fat, plant-based food, couscous and the like. When you teach them the right way, she was able to show they can actually learn how to use that food. They go home and tell their mothers, and their mothers change. And so it's not a question of, you know, children not liking this kind of food. That's simply nonsense. These children can, in fact, learn that food and learn to eat it, enjoy it, and change their habits. But what's standing in the way is the political pressures and the power of the industry and the government in just sort of keeping in place this awful program, this school lunch program. It needs to change. I thought a great deal about why is it, and how can we actually get this before the American public? And there's different ways of doing it, of course. But one of the ways that I could do it, and I think would be quite substantial, have a substantial impact, is creating this center of dialogue, you know, at a major university like Cornell. And I'm talking about creating a center of study that is funded by an endowment. It has to be an endowment. And the endowment has to be enough to create a critical mass. And I had in mind something like $30 million. And so I went out with my son and my Chinese colleagues to actually create some businesses a few years, 3 or 4 years ago. Now we've created some businesses, 2 of which are publicly traded, biotech companies, doing good things. But what I really wanted to do with that was to take the equity that I would get into that, give it back to the university, and that was the first 20 million. And then in turn ask the university to match it with 10 and get a total package of about $30 million. And that's enough, in my view, to create a center that would have a forever lifetime. In other words, we'd always know the money is there. It would have a forever lifetime, and to organize it in a way in which we would create dialogue. Get people from different interest groups to come together. And so presently I'm talking about how to put this together, whether to have a close association with the university, a modest association, whatever, but to engage at least the university influence in all of this. And then organize in such a way that we can have these sort of very deliberate and really, quite frankly, intense dialogues. I mean, we can spend a whole semester just talking about dairy. Get the dairy industry in along with the rest of us and talk about it. Or raise questions about genes and nutrition. Get the molecular geneticists in there. Well, let's talk about it. Because I'm really confident. Or the school lunch program. Spend a whole semester just talking about that, how terrible that program really is. And we can pick out these various and topics, and we have a means of publicizing this information to the media and so forth. Immediately transcribe, meetings and symposia and workshops, put it on the web, people can see. There's so much to be. I mean, we need to change the medical system. We need to change the scientific way of thinking. And I'm in science, and I know that, what I'm saying here has some very profound ideas on the way we design studies and interpret data. I mean, I challenge the whole field of epidemiology and the field of statistics, in ways in which I find are very fundamental. And we need to change our ways of thinking about nutrition. Because until we do that, it's going to be hard to articulate the message. And once we get that right and get some textbooks going and that kind of thing, we're going to have a difficult time. And I also am aware that there's some evidence, some pretty interesting evidence to show that, cooking does in fact cause a number of things that aren't very good. If you cook it a lot, you can get mutagens formed. Number one. Number two, if you cook it with water and so forth and throw it away, you lose a lot of nutrients. And you make a lot of changes in food. And I know there's advocates around, seem to be more and more these days, that getting raw food is a good thing. I just find this all kind of interesting. I would really like to get, in fact, that's one of the topics. I want to have a whole semester. I'd like to get the raw food advocates, come in and put your stuff on the table. Let's look at it, and let's make some comparisons here. If we don't have enough information at the present time to be convincing for other people, then let's go get the information. That kind of thing. We need to start someplace and start to talk about it. So it's just an interesting idea. In brief, the benefits of consuming a plant-based diet are comprehensive, profound, and can be observed in all kinds of studies with all kinds of human activities, including optimum athletic performance, including clarity of mind, if one wishes, certainly including optimization of health and prevention of disease. It's broadly based effects. It's impressive. And it turns out that this information, although we think we're discovering it just recently, is also very old. It's just simply been hidden from view for far too long. And now's the time that we need to start facing the facts and getting the story right so that we can actually create health, as I like to say, for individuals, as well as for their societies, and as well as for the planet. I mean, it has enormous implications. It's going to require a whole new paradigm of thinking.